Shock absorbers do more than just make your ride smoother. They counteract the bounce when you hit a bump, holding your tires to the road. Without that traction, you'd lose control. So by affecting steering, stopping, and stability, shocks are actually a vital safety component. Wheel vibrations cause a piston inside the shock absorber to force oil through a valve. This absorbs energy, dampening the vehicle's bounce. All this happens within the shock's two tubes, the reserve tube, and inside it, the pressure tube, housing the piston rod and compression valve. The factory makes both these tubes from a steel sheet sliced into strips. Inside this tube mill, coolant prevents the passing strip from overheating as one forming roller after another gradually rounds it into a tube. Then a copper welding wheel fuses the tube closed. As the 5.5 meter long tube comes off the mill, a cutting tool chops it into shock absorber lengths. The tube-making process is the same for the reserve and pressure tubes, except that the reserve tubes undergo one extra step, compressing the ends. This enables the shock to house a larger reserve tube that can hold more oil. The reserve tube's final stop is a press. A die inside stamps the part number, the manufacturing date, and the brand name. Many components are made of powdered metal, mostly iron powder mixed with some graphite and copper. After a press compacts the powder in a die, a furnace fuses the particles. This powdered metal part is the valve through which the piston forces the oil. Steel discs and a spring help control the speed with which the valve operates for varying driving conditions. A stamping tool crimps the end of the tube, holding the spring in position. The valve, now fully assembled, seals the bottom of the pressure tube. Meanwhile, a press punches round steel discs into other components. These loops mount the shock absorber to the vehicle. A worker positions a cup on each one, then a robot welds them together. They insert a cup and mount unit on one end of the reserve tube, then weld it on. This unit is called the base assembly. The base assemblies now go on a conveyor, open end up, so that workers can drop a pressure tube inside each one. Automated injectors now fill it with oil that's specially designed to maintain its consistency despite changes in temperature. Next comes the head assembly. That includes the steel piston rod and the mount on the other end of the shock absorber. Two copper welding wheels fuse the head assembly to the base assembly with a cap. This closes the unit, sealing the oil inside. Next, they weld on a dirt shield, a steel casing that prevents dirt from hindering the movement of the piston rod. Now they press a bushing into each mount. This helps tone down the vibrations coming from the vehicle. Now it's onto an automated carousel. Robots pierce a hole in each shock and inject nitrogen gas to prevent the oil inside from foaming. After injection, the robot seals the hole by welding on a tiny steel ball. And now for the finishing touch, an electrostatic paint job. A machine runs a positive electrical current through the shocks and a negative one through the paint particles. Like a magnet, the static electricity draws the paint onto the shocks in a flawless coat. In the factory's quality control lab, technicians use sophisticated equipment to evaluate how well a shock dampens movement at different speeds. The tube and valve configuration inside varies by vehicle, so the shocks on a ground-hugging sports car are quite different from those on a luxury sedan, or on a rugged light truck.